Good morning, good afternoon. How are you today? We are back again with another series for Visual BACnet troubleshooting. Now this time, a little bit more exciting, we are going to go through this live and troubleshoot a couple files that some of our very lucky Visual BACnet users have provided us. These are we've taken a look at these files a little bit ahead of time, as they're a little bit scary. There's a lot of interesting things that we found in this file. And I really hope that going through this session, we can shed some light on it and make troubleshooting on some of these problems, will make it a lot easier going forward. So I've got Ping here with me as well. So we've got a bit of networking expertise, a little bit of BACnet expertise, and we'll go forward and take a look at this file. This is our second file. This is from a hospital. This one has come to us with not as many problems, but a few. The overall health score in this file is 29%. And again, it was a good hour and a half capture, just about an hour and a half. So that's a good amount of data. There's not 2.5 million packets, there's 125,000. So it's going to be a little bit more easier on the network to troubleshoot. But this is pulling data from a network size of about 1,500 BACnet devices. So a pretty good sized network. As we can see going through this, there is, starting with the critical checks again, you see a whole bunch of unresponsive routers. But one thing that caught our eye right off the top is not necessarily unresponsive routers and devices, but I noticed this missing acknowledgements, which is almost 74% of the entire file is missing acknowledgements. What that tells us right away is that we were asking for lots of data and never got a response from what we wanted. So this is a spot that we would start with right away, because as soon as we go and figure this problem out, I'm pretty sure that the unresponsive routers, devices will come back, the broadcast traffic will drop, and along with a few, probably the longest response time as well. But we'll dig into that and we'll see what's going on.
Yeah, so a couple of notes here. On the far right side, far right column is missing ACKs. Right now it shows 100%. So every request that goes out, whether it's complex or simple, it does not respond. If we wanted to go back, and we won't, but if we went back to the other file that we were looking at, corporate building one, we would see some missing ACKs, but it's not 100%. So that typically indicates that the device is just too busy to process everything. But in this case, because it's 100%, it likely means that the device went offline. The programming is slightly incorrect, like it's looking for something that's not there. A router went offline. So basically, you know, the communications just flat out not working.
So one of the things you're going to do when you troubleshoot is figure out what it's asking for and then decide if that's supposed to be there or not. This particular one is the source destination is device 51,100. So it's the one that's asking for the information, and then it's trying to get the information from this guy here. We'll dig into the packet to see what that is. So what it's asking for is read property information. And it's asking for a so a confirm request. Confirm request means when you're doing a read, it's automatically confirmed because you're reading data back. It's asking for a multi-state output or an MO object, and it's asking for the present value. But what's happening is it's not getting that response. And then can we tell? So the destination, so the source, so it's going between the two networks. So it's asking from the source network address is where that 51,100 device is sitting on, and it's asking for the information from the 50,000 network.
A couple of tricks I wanted to show everyone here. So Ryan, if you hover over that first table there above, when you hover, you can see you can see it will pop up something. So on the very first row, it shows you the source, but doesn't show you destination. Just hover down to the next row, please, Ryan. And I'll explain what you see there. Source again, keep going down. Destination unknown, keep going. One more. There it goes. So this one, it popped up and it showed you both the source and the destination. All it is this is correlating data that we're having in other places in Visual BACnet. When Visual BACnet is able to find the vendor name, the BACnet ID, the source address, and sometimes that information is only available in frames like IAM or so on and so forth. Whereas in sometimes there are frames that all it has is a BACnet ID, or all it has is the BACnet address, the source address, destination address. So what this says is that this packet here, or this machine here, the destination device, we did receive like an IAM from it. So that's an interesting thing. Whereas in the very first row, you could see the source, but you didn't see the destination information, which is very, very consistent with what we're seeing here, because we weren't able to gather additional information on the destination machine. Just little tricks in the Visual BACnet.
Perfect. So under here, under all those files, we've got, we're looking for a lot of information that's not giving us a response. So this one here was the MO object. This one here is, again, looking for another multi-state output. This one here is looking for an analog output. So the common theme here is you're not getting any data back. So the source would be, first of all, check this device right here, 51100, and determine is it asking for the right information? And then if it is, then we can turn our attention to the device that should be giving it back to you.
Yep.
So coming out of that, if that's true, then we should start looking at the routers, because odds are the information trying to go from one part of the network to the other is going to continue from here. So now when you're looking for different BACnet routers, you've got this destination network is sending a whole bunch of information. It sent 343 packets and none of it got an answer. So is the device online? Is it even supposed to go that way?
Yeah.
And here, you had something, Pink?
No, keep going.
Here you've got a querying device that sent packets. So we know exactly which device it is by MAC address. And then we can go see what it's actually asking for.
Yeah. So this is, it's kind of neat that we had these two files to compare. The corporate building file that we were looking at earlier, we had excessive amount of global whois router to network, whereas in this one is what we call a targeted whois router to network. So this message is being sent by this querying device saying who is the router to network 20528. And it's not getting a response. It's not getting an IAM router to 20528. So that's a normal frame, a good frame, but for some reason it's not responding.
Correct. So a lot of whois router to network here as well. And this is different than the global whois router, but this is saying I'm trying to, this device is trying to send data to this network and I don't know where it is.
Yeah, and one thing you can point out, Ryan, if you scroll up a little bit, that first table shows you the destination networks that are being requested. So Ryan clicked on 20,528, and when he clicked on that, there was only one device that was asking for this network. Okay, so the good news there is that it's likely programming on this device, as opposed to seeing 50 querying devices looking for this network. I don't know anything about the system, so I can't say for sure, but if there were more than one device looking for this network 20,528, it's likely that the router went down. But in this case, because only one device is looking for this network, it could be that this device has incorrect programming. We did a copy and paste, we moved the database around, whatever it is, we changed the router, we never updated it. let's click on a couple more just to see, just to compare. That
Here's
you see
another
that
one.
one? Yeah, that
Here's
one's
another
new,
one with more
right?
crane devices.
Yeah.
This, keep in mind, during construction, you may see a lot of this where you would have programming in the device before the other zone devices are up and running. But look at the impact it does have on the network, even during construction.
Yeah.
So as being stated in here, there's 4 querying devices trying to get to this network.
Yeah, and here is sending it every minute.
Yeah, every minute it's taking a look. So it's trying to get to a different source port. And this one through here, this is the original broadcast, so it's still within the same BACnet segment.
Mhm.
And again, router to network. And all of these are very similar, coming from the same network. The second that the BVLC function goes to forwarded MPDU, then we know we're crossing BBMDs.
Correct.
So a little bit of work on there to figure out, looks like you've got some work to do, Phil, to figure out what's happening on this network and targeting these querying devices on the source. So it looks like your router and your missing acknowledgements are going to be related.
Yep.
Now, if you pop back into this file, there's another piece that we wanted to look at, and that was, well, there's 3 things I want to look at actually. One is the BACnet broadcast traffic. This one here is this device here, the broadcasting device. It's sending an awful lot of information in this file. Remember, the file itself was only 125,000 packets, so almost 15,000 of those are broadcast device. We're trying to figure out what it's actually sending. Who isn't really a big deal. The unconfirmed private transfer, this is more of a proprietary information. So it's sending these fairly consistently. See what else is here on the network. So a bit of a combination to both. I don't recall ping the unconfirmed private transfer probably shouldn't be a broadcasted device. I think it should be a direct unit.
Yeah, I'm a little surprised there, although I don't know enough about the private transfers to comment intelligently, but that'd be something to look into.
This is probably sending up like trend log data or something else, but it should be sent to one direction.
Yeah.
So you might want to check your data exchange settings and see what's going on there. And if you can tone that down a little bit. The other one that was interesting to us was this alarm. So what the alarms do is we trigger the alarms if they go from normal to off normal within the length of time within this capture. So what we're seeing here is there's an event enrollment alarm that has gone off, and it's gone. So here's the event enrollment device or object type, and then it has the object instance is 9. So what it's done is this is triggered 12 times over the past hour and a half file. So that's pretty consistent. If your alarm's triggering that much, I mean, a lot of times the alarm should trigger almost never, if anything, every couple of days, depending what the problem is. But this is a consistent problem within the hour. So from here, obviously, it's hitting the high limit a lot and then coming back. So it keeps flipping back and forth, back and forth. And it looks like this is hitting 4
times, it looks like.
Yeah, it's pretty consistent, isn't it?
Mm-hmm. Yep.
It looks like about every
4 times to 4 different destination, or can you expand the Ethernet header? So no, it's broadcasted. So I don't know why it sends it 4 times. I'm not sure.
device 63.
Maybe there's different data in it. Expand the APDU, Ryan. Yeah, so it looks like it's sending out a bunch of stuff. I'm not too sure. I'm not too sure, but that'd be something interesting to look at.
Seems like the same piece of data. So this is looks like a filter alarm based on pressure. So something here is probably alarm. The alarm value is a little tight, and it could just be reduced. Or maybe it needs a lockout, something similar to that. But it is I mean, obviously, as we know in BACnet systems, and if the alarms aren't tuned correctly, then you're going to have quite a bit of data. And as we all know very, very well, if there's too many alarms, they get ignored. So this is a really good indication of seeing the same alarm triggering back and forth. And it's a way, the way we identify it means the alarm is triggering on and off way too much. Normally in most files, we never see this trigger.
Yeah.
And then last but not least, we have a longest response time. Now, oddly enough, between this file and the last one, they're both at 6 seconds, but that's purely a coincidence.
Yeah.
But where it helps you here is this requesting device is asking data from this device over here, and it's taking 6 seconds to respond. As a quick note, inside of all BMS programming, if you set a device or if you set a data request from one device to another, we can always time it. So if you suspect your system is slow, set a start and source and end destination, and we can simply time it and see how fast it's taken for data to get through your network. Yeah. I know when customers say my graphics are slow, I mean, that is a very, very, very vague problem, and it takes a while to go search, but this is a good way to see it. So what we're asking for here is from those two devices, we're actually asking for some information from the device object specifically, and we're asking for all of this information. So it's a read property multiple that's trying to send all this information back. And it's taking 6 seconds to collect that data, which is way too long. But we know what device it is, we know what the two controllers are. So the job you're going to have now is to determine in a BACnet network on what's in between source and destination device.
Yeah, and a couple of notes here, 3 notes. One is the response actually it's successful, right? So you can see it sends out a read property multiple and actual response with the acknowledgement for the read property multiple. So it is actually working. So the data is getting there. It's just getting there a little late. Observation number 1. Observation number 2 is that at least for the top 10, it's all the same requesting device. So, you know, what's happening there? Again, I don't know the system. I can't comment. And observation number 3 is that unlike the first file where we looked at, and there were a lot of messages that took 6 seconds and above, in this one, there's one pair of messages, one thread that took 6.3 seconds, and then it drops immediately down to 1.2. So the good news here is that it's not a problem across the entire system, right? Something happened between these two devices at that time that took 6.3 seconds. It could be that responding device, someone logged in and did a big, you know, graphics grab, and it just chugged along for a while, and the CPU was locked on that, and then it went back to normal. So the good news there is that it could just be an anomaly. It could be just that one device, or it could be just on the cusp, and therefore once in a blue moon, you get a very, very long processing. Unlike the first file we looked at where we had a consistent over 6 seconds, and in fact, they aborted that one.
Perfect. So there you go. We've got some work to do and getting through it. Odds are some of those routers may be a problem in here. They probably are a problem. They could be causing some of this delay. But we've kind of given you an order to look at. Definitely look at those acknowledgements in as well as those unresponsive routers. And this network is going to be golden very, very quickly.
Yep. One quick note from the audience. It was good advice here. When we are troubleshooting, especially look at a system that's a lot bigger, it does help sometimes to look from different point of views. So someone in the audience suggested, coming back to that corporate building file example, if we pulled a file from that 10.200, 254, 200, it might give a different perspective of what's happening. So very, very good point there. When you're troubleshooting something, when you're evaluating the health of a system, it does help to take captures from different points. If you might have MSTPs, it'll grab it from the BBMD. If you can do mirror reports, a great way to do it also. Yeah, thank you for that.
Always helps out both sides of the conversation.
Yes.
Alrighty, great. Please ask away on any questions. That's all we have for these two files. I hope you found them very informative. As always, we at Optical Networks are here to help. If you're stuck or struggling with a file, we are happy to help. If you're stuck in capturing and trying to get the data, we are also here to help. This is what we do. We live and breathe this. So anything we can do to help you, that's what we're all about. That's why we created this. BACnet's great, not without its problems like anything else. And we just want all your sites to be perfect.
Quick question from the audience. Can the BACnet browser in Visual BACnet show messages between two devices for write to a specific instance of a specific object? It is not currently possible. I think for the question, we'll take that as a feature request. And if you do need help, let us know. We might be able to script something up custom for you, but it is not currently possible.
Yeah, not at the moment.
Yeah.
However, out of curiosity, we can look at, where was that? So in the other file with the unconfirmed traffic, so even at this one here, this is showing us the object instance. So we can, I believe you can do a search inside of this to look at the object instance. So inside of this, if the data is already being sent, then there's a portion of it that we can narrow down.
Yes, good point. Actually, you can do the same. So this example, this question was about write properties. So let's see if there's any write here, Ryan. Let's go to summary, write property. If there are not, we'll look at read property. But I believe Ryan's right. There is a way to do it because so there's no write in this file. Let's see if there's some reads. I believe there are.
I'm not sure if we can get that out of the type.
You can, but it's digging in a little bit, right? If you want to look at a certain object, you have to open up the frame and look at that. It's a little clunky there. It will be under service choice, I think, Brian.
Yeah, I think you're right.
So there's no write property you can see here, but there's some read property. So let's go back to summary and look at the read property. You might be able to get, again, if there are write properties in your system, you might be able to use that write property check to pinpoint that specific object you want. But for example, here we'll use a read property. So here it does pull out the object instance. If you know what instance you're looking for, you could sort or search for it. It might give you the information you want, and it will also give you, I think it'll give you both the request and acknowledgement. Can you click on one of them, Ryan? I just want to make sure that I'm not providing incorrect information here. Right, so there's no response time on this one. This one might be the one with a lot of missing acknowledgements. But I think you might be both frames. There it is. Yeah, wonderful.
Perfect. So there is a method of doing some of this.
Yeah. Hopefully this helped.
Yeah, echoing what Pink started to say. Hopefully this helps. We do these periodically every couple months, or every 6 months. So if you're stuck, get a file ready, and we'll help troubleshoot it. Till next time.
Thank you. Stay home, stay safe.